Welcome everyone to my LeetCode weekly contest 420 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video descriptions. In a few minutes, we'll be doing the contest live, we'll be answering questions and giving hints in the chat. So join us every weekend for the contest. No code will ever be shared while the contest is running, but immediately afterwards, we will go through solutions for all 4 questions. So make sure you stick around. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright, so the contest will start in about 10 minutes. And usually I'm gonna look around and see who's around tonight. It looks like a pretty small crowd. But, you know, people shuffle in. I guess it's a morning for many of you guys. As usual, since we're waiting for a contest to start, I'm going to look at the daily problem and see if we can make some traction here. So daily problem is parsing a Boolean expression. A Boolean expression is an expression that evaluates a true or false. You have all these different cases. This looks like basically a parsing problem. A parsing problem that I think is fairly standard. So the general strategy is to create some kind of stack. And then use that to parse these expressions. Okay. I'm also going to create a structure called sub-expressions here. Sub-expressions here, basically what that does, basically what the sub-expressions do will be to collect a bunch of sub-expressions. I wonder if I can do this. I don't know if I can do this. Probably not. I might have to put the expressions on the stack itself. Yeah, I might have to put the expression on the stack itself. But okay, let's see how we can do this. Okay, so the first part is pretty straightforward. It's some kind of match. So I want to see what C is. If C is T, case F. So basically the 4 cases and this is more interesting. These open and closed cases are more interesting. Okay. N and or, not N and or. Okay. We're gonna assume that these are valid. So I'm not gonna even bother with being valid or invalid. So when I see a T, what I want to do is I want to just replace that with an expression that is a T. I'm going to eventually pass this into some kind of abstract syntax tree. So I guess now, okay, welcome. I see a bunch of people just join. For those of you who are wondering what I'm doing, I'm just working on the daily problem, since we're waiting about another 8 minutes before the contest starts. So today's daily problem is hard, so it's probably going to be a good warm-up for the contest itself. Yeah, if you're here in the stream, make sure you say hi. Especially if you're a regular viewer, I'm always very excited when I see my regular viewers come on. But of course, for weekly contests, usually people are not that into it. Okay, so I'm probably gonna make this some kind of Python enum. So true, false, and then not, and or. So what I'm doing here is basically I expect to make some kind of enum. I'm gonna have some kind of yeah, I'm gonna be in a place where I am going to have children, because the not and all have children. So if this is the case, all I have to do is to say stack.append what is this? expr.true, I think. I forgot the enum syntax. Or is it just true? So essentially what I want to do is to put things on the stack. And when I see an open, I'm going to add an open to the stack. And then when I see a close, what I'm going to do is I'm going to take everything up to the close and put them into a list. Hello everybody who just joined. Welcome, welcome. I'm just doing some warm-up problems before the contest. The contest is about to start soon. We're going to do some warm-up problems. 5 more minutes. Today's warm-up problem, today's daily problem is parsing a Boolean expression. So it shouldn't be too difficult. I hope not. So I'm going to do stack.pop. If current equals to open, then break. Otherwise, I'm just gonna add pen current. So I'm just gonna add this to the end of the previous to a set of sub expressions. So this would pop all the way until I get So basically what this means is that if I have open parentheses, true, 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 whatever. Oh, actually I have to have a case for the comma also. But I'm not sure if the comma actually does anything. I don't know if the comma does anything. It might be a pass. Because we know all the commas, right? The commas are kind of fixed. The commas are fixed. While stack. Yeah. So while stack. Not while stack. It is while true. Because basically what we want to do is we want to, the stack will look something like this. Open, true, false, false, true, close. And then there's more stuff here. This might be a not. This might be an and then there's like a not here. So there's quite a bit of stuff. We're not gonna pop the whole stack. We're gonna pop until we see an open. So when we see a close, what we want to do is to pop until we see an open. Take all the sub expressions, put them onto a stack. then now this is the interesting part. If we see a not, what we want to do, when we see a not, we expect that the next thing is a sub-expression. And we've just done the open thing. So what we want to do is we say stack.append. Let me see. This expression I probably shouldn't do expression this way. Yeah, or I can do expression this way. Okay, well, time is almost up. 36 seconds. Let's see who's around. So we have 13 people around. All right. I hope you guys are warmed up. We're getting ready for the contests. Welcome, Ayo, also Novo. I'm terrible at saying people's names. So if I mess up your name, don't get mad at me. If you need help, reminder once again that I don't code on the screen that I'm sharing. But if you need help, write in the chat. I code on my separate screen. And that's because I want to not show answers until after the contest. Oh, wait. Okay, contest is begin. Good luck, everybody. Hey, Websleek, good to see you again. Hello, good morning. Once again, folks, if you need help, type in chat. I code on the second screen, so you can't see what I'm doing. Hey, Sriman, good morning. Good morning. Welcome, everybody. Good luck for the stream. For the contest. Today's questions look, they have a lot of points, so I wonder if it's going to be hard. You're given a string target. Alice is going to type target on the computer using a special keyboard. All strings that appear on the screen as Alice types target in order they appear using the minimum key presses. Oh, this is annoying. Okay. So let me just present the question. Because I know some of you guys actually don't do the contest, you're just watching. So if you're watching, oh, oops, I should hide this. So you're watching, hopefully you can see a little bit. Yeah, so the output is a bit annoying. You type A and then you turn that into A, B. All right. Anirudh Sharma, help right away, so fast. Wait, you got to try it first, man. You got to try first before you ask for help. Does the question make sense to you? So basically, you want to type ABC, right? The only two keys are either you add a new character or you make the last character go up. Yeah? So try out yourself first. This question is not that hard. So try out yourself first, and then we'll help. And then I'll help, I promise. Yeah, this first question shouldn't be that difficult, I hope. So if you need help, yeah, try out yourself first before asking for help. But if you do need it, just let me know. I will do my best. Okay. So question 2. Count substrings with k frequency characters 1. Is there? Nope, there's no count substring with frequency characters 2. Given a string s and an integer k, return the total number of substrings of s. Where at least one character appears at least k times. Okay? A substring is a contiguous, non-empty sequence of characters within a string. So, at least one character appears at least k times. Let me just see. Okay, so s dot length is 3000, so you cannot brute force this. You probably need some kind of sliding window. Do you start question 2? Yeah, I started question 2. Welcome, Raihanu Bari Tanvir. Yeah, I'm doing question 2 right now. So Mohan Krishna Tala, what language do I use to code? I use Python. Python, I think, is the easiest for this kind of competitive programming problems. So total number of strings of s where at least one character appears k times. Okay, sounds like a sliding window problem. Total number of substrings of s. Okay. And this is any character appears twice. At least k times. Okay, so any character appears twice. 2 times or more. So for instance, if ABA, so ABA, A here appears twice. BACB, B appears twice. So basically, for all the strings starting with A, ABA is a valid substring because at least one character appears twice. Then everybody containing ABA will be valid. So you can sort of count from there. Alright. So if you need help with question 2, just let me know. I think question 2 is a bit harder. Question 2 is a standard sliding window. Actually, let me just write it down here, because I'm sure people will ask for help on this. Question 2 is a sliding window? Think about it yourself. Yeah, just think about it yourself. We'll come back to it later. So again, if you have question, just ask for help. Otherwise, I'm going to be pretty quiet this stream. I'm actually trying to break. So my rating was above 2,000 for a while, but then I fell under 2,000 because I was slacking off. So I'm trying to go back to above 2,000 again. Hopefully this contest I'll be able to do it. So I might focus a little bit harder on a contest. If people don't ask questions, I might I might just slack off. Do 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 do. Okay. When you do move the left pointer in the sliding window, when do you move the left pointer? Great. Good question. So you have, let's say, well, I guess the answer is always, right? Because let's say you have A, B, oh, oops, I'm on the wrong screen. Let's say you have A, B, A, C, B. Your left pointer is here. You want to see where your right pointer is. Your right pointer will be here. And then your result, your total is equals to 3. So 1, 2, 3 when your left pointer is here. When your left pointer is here, your right pointer has to go all the way to the end. And then your total is going to be 1. So you basically keep moving the left pointer. You move the left pointer and then you move the right pointer until you see a valid string, and then you keep going. So that's the basic idea. I'm not gonna give you any. I'm not gonna say any more hints than that. Yeah, good job, Mohan. Good job. Give some hint for question 2. Yeah, so the hint for question 2 is on the board. It's basically some kind of sliding window. This is all the hints I'm willing to give, okay? So your left, you start with your left at the first character. You slide your right until you get a valid string, and then you count how many valid strings these are. So because your right is not at the end, there's going to be 3. And then your left move 1, and then you slide your right all the way in. So you keep doing this until until you're successful. Okay, let's see. Ah, crap. I got a wrong answer. 1, 2, 3, 4, 5, 6, 7. So I got a weird bug. Huh. I have some weird bug on question 2. Damn it. Okay, question 3. Minimum division operators to make array non-decreasing. You're given an integer array nums. Any positive divisor of a natural number x is strictly less than x. It's called a proper divisor. Okay, cool. You're allowed to perform an operator any number of times. You select one element from nums and divide it by its greatest proper divisor, and then return the minimum number of operations required to make the array non-decreasing. So let's see. You can only numbers can only get smaller, right? So 25 if you want it to be non-decreasing, everybody has to be smaller than 7. Which means the guy before 7 must be divided by its greatest divisor enough times to make it non-decreasing. Yeah. How do I find factors of something? Okay, so let's see. Probably what I want to do is to start from the end. It's non-decreasing, right? So it'll go up or equal. So I start from the end. The last guy cannot change. Oh, yeah, the last guy cannot change. Yeah. So if the last guy cannot change, then yeah, okay. So that's the basic idea. So first, probably what I need is a way to find all the divisors of a number. That's my plan. Is to start by giving have some kind of function to find all the divisors of a number. Well, all the factors of a number. Oh, actually, I don't need to find all the factors. I need to find the largest factor. Then probably what I want to do is just go from for f in range square root and it will stop before it reaches 0. So yeah, so I have to find the largest okay. Gonna see if there's any questions. Oh, it's a very quiet night. Nobody asking questions for some reason. Yeah. Well, for this one, the plan is not. The plan, probably what you want to do is for question 3, you want to work backwards. The last number cannot be changed. You want the last number that's as big as possible, right? So the last number cannot be changed. So you can only divide by the largest factor. You cannot divide by a factor that's not the largest factor. Oh, actually this is the greatest proper divisor. Okay, and you return how many operations you do, right? Return the total number of operations. Alright. So this shouldn't be that difficult, I think. Okay. Let's run it. Famous last words. Int and none type. Okay. Damn, I'm having a lot of bugs tonight. I'm gonna lose a lot of time. Five minutes each time you make a bad submission. Third question, 314 or 7114. Yeah. Oh, do you know what the problem is, Mohan? It should be quite fast. I don't think this is like, there's nothing clever about this question at all. You just do it. It's normal. (105) divided by 7 is 15. Why is it 1? That's interesting. What? Man, I have so many mistakes in my what you might call it. Best is 18. Okay. 16. Why is this 1? Oh god, I have so many bugs and careless mistakes. Hopefully this works. Please. Please. Okay, finally accepted. Okay, cool. Let's see question 4. TLE on question 3. How do you get TLE? Yeah, question 3 I had 3 bugs. I got my factor function wrong. But how do you get TLE for question 3? That's interesting. How do you get TLE for question 3? Question 3, you should. I just use brute force. Okay, so maybe I'll drop some hints and see what you guys are doing. I'm kind of curious because so the basic idea is this, right? You got an array, so you start from the back. Oops. So you start from the back. Or whatever. You start from the back and you work backwards. So you start from the last guy cannot change. So every number you can only go down, you cannot go up. So last guy cannot change. You need to bring this guy. You need to bring this guy to be smaller. 25, 5. It needs to be smaller or equal to 7. That's what you need to do. So you have to keep finding the highest, the greatest common divisor, and then keep dividing it until it's smaller than the number here. How do you find the greatest proper divisor of a number? You just go from 1 to 100, right? So you want to know the greatest divisor of 25? You start from 2. Is 2 divisible? No. Is 3 divisible? No. Oh, 5 is divisible? Okay. Then 5 is, then the greatest proper is 25 divided by 5. So you just do like, I just did a for loop here, and that works. How to get the greatest common proper divisor? You just do brute force. You go from smallest number to biggest number, and you see which one divides it. So the only thing is, instead of going from biggest to smallest, you should go from smallest to biggest. Smallest, biggest will make it a little bit faster. Yeah, but still, I'm surprised that it's a TLE. Okay, sorry. I need to. Yeah, I'm surprised. I'm a little bit surprised that you get a TLE there. Okay, so I have a bug in my question 2 that I still need to fix. Ah, damn it. I have so many errors. Drat. Okay. It's alright. So 4, 15, and 7. So this should be right. Please. Oh God. Okay. Wrong again. Why? Okay. Don't let me down. Please. No more bugs. Yes, accepted. At last. Okay, finally I can work on question 4. Wow, this contest has been a slog. Okay, let me look at the thing. How do you get TLE on question 3? So question 3, just do brute force. Just do brute force. You want to find the greatest common, the greatest proper divisor, right? Just do brute force. You want to find, you want to find the greatest proper divisor of n. Just do check 2 and divide by 2, or n remainder 2. Is it 0? If it's not, then check 3. Then dot dot dot. Keep going until you find something that until you find a number such that n divided by the number is equal remainder 0. So find the first divisor and then you do that. That should work. I'm pretty sure that should work. Unless it's a Python versus Java thing, which I will be quite surprised by. Okay, anyway, let me look at question 4 first. Yeah, I don't know how you guys can get TLE on question 3. Yeah. Also, while I have people here, just a shameless plug since we're sort of halfway through the contest. Just a shameless plug. If you haven't subscribed yet, you like what you're doing here and you haven't subscribed, please subscribe. If you can, please hit the like button on the video. Yeah, that helps me out a lot. I try to ask people for this while the contest is running, because after the contest, most people will go away. Okay, let me look at question 4 first, and then I'll come back, give question 3 a try. I'll come back and help with question 3 later. Okay, so question 4, you're given a tree rooted at node 0 consisting of n nodes from 0 to n-1. The tree is represented by an array parent of size n. A tree rooted at 0. Okay. Okay, so it's a parent array. This is a parent array. Since 0 is, yeah, okay. You're also given a string of length s, where si is a character assigned, okay. Consider an empty string. Define a recursive function that takes a node x as a parameter and perform, oh my god. This is so many words. I feel like LeetCode now is just adding a lot of extra words to confuse you. This is an English challenge, not a programming challenge. Define a recursive function dfs int x. that takes a node x as a parameter and performs the following steps in order. Iterate over each child y of x in increasing order of their number. Call DFS y. Okay. Add the character sx to the end of the string, shared across all recursive calls of DFS. Okay. So basically, this looks like a depth first search. So this is an in order depth first search. No, this is a postfix. So this is important. So first children, then yourself, right? So this is postfix DFS. So it's a postfix order DFS. You need to find a Boolean array answer of size n. For each index, you do the following: empty the string DFS and call. Oh my god, this is so confusing. If the empty the string and call DFSI. If the resulting string DFS stir is a palindrome, then set answer I to true. Okay, this is such a fiesta. Okay, cool. So you've got a. Okay, so this is actually not hard. This is actually an easy problem. I don't know why this is known as hard problem. This should be an easy problem. Okay, so you've got you got a bunch of stuff, right? So what you want to do is for each guy, you to compute his DFS string. So DFS string of, let's say, number 2 is the postfix traversal of his subtree. So postfix traversal means you traverse his children first. So children is A, and then yourself is B. So that gives you AB. Yeah, so that's the basic idea. Yeah, that's the basic idea. So your children first. And so the other thing that that's interesting is that, yeah, so that one is quite simple. So step 1, I guess, is just to find what is the DFS stir. Calculate DFS stir for all the nodes. And then check if they're palindromes. So the challenge here is that this is a very large number. So you cannot even use n square algorithms. Yeah, so this is a super large number. You cannot even use recursion. If you mess up your recursion, you would die. Well, not actually die, but if you mess up your recursion, then this would not work well. Yeah. Yeah, I don't even know if, because the size of n, I don't know whether you can use recursion or not. So let's see how I can do this. Let's see if I can do this recursively. Okay, first step is we need to calculate DFS stirs. Yeah, actually first step is we need to calculate all the child nodes. DFS stirs. Okay. No full code. Sorry, I'm going to Yes. So sorry, G Megan Nan. We don't give code here. Q4 is, I think, in DP approach. Why do you need DP? Can't you just going backwards make more sense? You can go backwards too. I don't know whether backwards will work. Okay, think about it. Think about it. So question 3, right? Question 3. Think about it. If you want to find the factor of n, okay? Largest factor of n. The largest factor of n is between 0 to n minus 1, right? Somewhere there's this thing called square root of n. Any factor that's larger than n will have a complementing factor that's smaller than the square root of n, right? So for instance, n is, let's say, 100, right? So you want to check for the factors of 100. You need to check from, whether 100 is a factor. You just go from 1 to 2 to 10. You don't have to go above 10. You just check up to the square root of 10 n. If you check backwards, you have to check from n minus 1 to square root of n. You check forwards, you go from 2 to square root of n. So this is actually much faster because this number is much, much smaller than this number. I think that might be why you guys are having a TLE. Does that make sense? So if you want to find the largest factor of 100, right? Largest factor of 100. You don't go from 100, 99, 98. This is a waste of time. You start from 2 first. 100 divide 2. Is it a factor? Yes. So largest, 50. I equals square root of n, I think. Or n over 2 also can. Yeah, that's a good question. I don't know. Whatever works for you. I did square root of n, so it's I did a little bit faster. Yeah, respect for not sharing. Yeah. I mean competitive integrity. Also, the point of this whole thing is to learn. So if you don't try yourself, you're not gonna learn. Even if you get LeetCode number 1, you get gold medal, gold star, it's not gonna help you, right? Is the goal? Yeah, it's not gonna help you. The goal for all of us is to learn and hopefully get better at coding interview and get a job, or better at programming in general and get a job. Construct the DP array size n and go with reverse last to 0. Yeah, go from bottom up. So it's not last to 0 if you go. It's not bottom up when you go last to 0. Because the parent doesn't have to be smaller than the child. Yeah, third question, the hint is on the board. I'm gonna need some time to work on question 4. So I'm gonna zone out a little, I'm gonna veg out a little bit. If I finish question 4, I'll come back and talk to folks. So hang in there. Yeah, so question 3, hint is on the board. You go backwards. The last number cannot be changed. So the second last number must be smaller than the last number, and so on and so forth. Finding GPD, I think is everybody's biggest question. So that one, start from the smallest number. And another bonus hint is check your code properly, because this question 3 has very bad test cases. Even you pass all the test cases, your code still might have a lot of bugs. So I just passed all my test cases, I click submit, and I got penalized a lot of time. So don't be like me. Yeah, at the bottom. Okay. Okay. Sorry, I've been quiet. I'm trying to do question 4. So, bro, for 4th, I got TLE. I passed 500 out of. Oh, wow, sucks. Is it the way you construct your DFS string? I feel like... Yeah. I think it might be the way you construct your DFS string, if I'm guessing. because you have to consider the case, like you want to find. So for question 4, the tricky part is you want to find the sort of root nodes, right? You want to start with the root nodes, right? You want to start with like this one, this one, this one, this one. You want to start with the root nodes first. How do you identify the root nodes? It's actually not that easy. It's actually not easy to identify the root nodes. If you just go backwards, if you do it naively, you get n squared. If you go backwards, it was not going to work. For some cases, you'll get a wrong answer. So my guess, I have nothing to back this up, but my guess is my guess is maybe it has to do with the way you create the DFS string. Anyway, I'm still working on it also, so I don't know if I'm doing it right. Okay, let me see. ABA, AB, ABA, okay. Yeah, another thing is how you check whether it's a palindrome. Checking there's palindrome is not that easy. If you just naively check whether something is a palindrome, it's not going to work also. Yeah. Explain the test case of 2, 3 in question 3. Okay, WebSlick, let me see if I can help you with this a little bit. For question 3. So example 2 and 3. So question 3, you want to make sure it's non-decreasing, right? So for non-decreasing, question 1, 25, you divide it by 5, you get 5 left, and you have 7. And so you do one operation on this guy to get 5. So the answer is 1. For this, 7, 7, 6. Okay, if you do one operation on this guy, you immediately get... Yeah, it has no operation on this guy. There's no operation. So the valid operation, if you look at the definition, 7 is not the greatest proper divisor of 7, right? So 7 has no greatest positive divisor. So 7 doesn't have a GPD. So in this case, the answer is -1 because it's impossible. So 1, 1, 1, 1 is already non-decreasing. So the answer is 0. So that's a test case. Yeah, I'm also having problems with question 4. I also have the same problem with question 4. Yeah, I also have. So I guess you sort of naively find the... You try to find this naively, right? Let me see. How do you... It's a tree, so there's literally no better way of doing it. Ugh. Yeah. So I'm guessing there's a way to check the DFS which is faster. Wrong answer for 711 out of 7. So let me see if I can help. I also got stuck 580 out of 583. I think there's a way to check the... How do you check the DFS that is faster? Check palindrome that is faster for a tree. I think that's the trick. How do you check if the thing is palindrome? Because because all the branches of the tree are new, right? You've never seen the branches of the tree before. Let me see. If this is not a palindrome, can these things be palindromes? Maybe they can be. Yeah, I don't know. So question 4 is kind of hard. I'm also kind of stumped on question 4. Okay, so let me read the chat. So also wrong answer on 711 or 714. This is question 3, right? Yeah, let me see. Let me see if I know what it is. Because I got so many of them wrong. Maybe you got one of mine wrong. Yeah. Nope, I don't have it. I didn't get stuck on 711 out of 714. You're starting out storing children DFS of each node, and when we reach the node, just append that. What do you mean? You reach node, just append that. Yeah, you can. So I don't know whether... Okay, there's two parts, right? One part is creating the DFS string, and the other part is checking if there are palindromes. I wonder if... the trick is to not create the DFS. Yeah, I wonder if the trick is to not create the DFS strings. DFS, what kind of traversal? So if you read the question carefully, you traverse the children first, right? You traverse children first, then you traverse yourself. So you know, yeah, so Raihanu, yeah, so you know it's post order. Because you read the question carefully. Iterate each child first, and then add yourself. Yeah, so yeah. Yeah, there might be a way to make it faster. Yeah. Let me see if there's a way to make it faster. So so G2G, I think you might be on the right track. When we reach 1 from 0, we use the DFS string. Yeah. So G2G, you're on the right track. But even doing that, I still don't think it's fast enough. Yeah, so that's what I did, and it's also stuck at 580. I'm also stuck at 580 out of whatever number. $580 out of 8. 583. So I think the trick is you cannot create the string. If you create the string, it'll be too big. So you shouldn't create the string. You should not create a string. I think so. So if you create the string, it's probably going to be too big. Hmm. Sorry, a little bit quiet because I'm trying to. Ah, damn it. Sorry if I'm being a bit quiet because I'm trying to last ditch effort just finish this up. I'm trying to figure out question 4. I think I know what it is. So every child only has one parent. DFSC equals if parents P larger than I and DFS P okay. Stirs P. Sorry if I'm quiet. I'm just last stage trying. Can you use try in question 4? I have no idea. I didn't use a try. Giving up is not an option. Yes, giving up is not an option. Try. I'm also trying. I got 9 minutes left. I don't think I'm going to succeed, but I don't care. I'm going to try. Okay, last ditch effort. 7 more minutes. 5 more minutes. Giving up is not an option. Okay, cool. Okay. Please let this pass. Please let this pass. Get out of the print statements. Please let this pass. I bet it's going to be 580 out of. Okay, can we use try in question 4? I don't know. Sorry, I wasn't looking at chat because I'm last minute struggle to make it work. Break after smalling. Wrong answer for output 2 experiment. Yeah, so web slick 105.11. Yeah, you need to find the right. Yeah, it's you found the wrong greatest common denominator. All the solutions are TLE. We'll go through it. So guys, don't panic. 580 out of 8. Time limit exceeded. It's still the same. Why? Yeah. Okay. I think I give up. I thought this is the fastest I can do. TLE. I fixed the space problem. Yeah, I don't know. I don't know what's the right answer for question 4. I thought I was doing something pretty clever. Pretty clever. But I guess not. Yeah. So let's see. Yeah, I feel like there's a way to do this. There's like a clever way. Okay, I'm gonna read chat. Okay, well, while I have folks here, once again, reminder: if you like my content and you haven't subscribed yet, make sure you subscribe so you know when I'm streaming again. I stream every week. I stream the bi-weekly contest. If there's no bi-weekly contest, I will stream the weekly contest. So I stream once every week. If you enjoy my content, I really appreciate it if you just click the like button on the video right now. Yeah, that would be helpful. So Raihanu Bari Tanvir, that's exactly what I did. I make all the strings exactly once, and when I don't need the strings anymore, I threw them away. So I thought that I would for sure not get TLE, but I'm wrong. I'm wrong about this. Yeah. Well, let me think about it. Let me think about it. Let me think about it. So let's say you have a palindrome, right? You have A. For this to be palindrome, this must be the same as this. A and A. Right? This is the very last element and this is the very first element. So A and A has to be the same. What is the second element? The second element is probably, is probably this guy. Second element here. Second and last element is this guy. So third element. So the third element is this guy. And then the third last element is this guy. I feel like there's a mathematical way to do this. There's a mathematical way to do this. So for this thing to be palindrome, this and this has to be the same. And then this and this has to be the same. I don't see the pattern though. I really don't see the pattern because finding the palindrome for this doesn't help us find whether these subtrees are palindromes. They're all completely jumbled up. So I don't know. I feel like I did the same thing as Rahainu, which is I also made sure I made the strings once. And then when I made the parent string, I deleted the old string. So I don't keep a lot of like random strings around. Yeah, once I make the parent, I delete the string. So I thought that I already did my best. I only make each string exactly once. I don't know. Okay, anyway, this is what it is. It seems like some of you guys got 711 out of 714. So Edward Lee, you got 713 out of 714 in Q3. Yeah, a lot of you guys got TLE in Q3, right? Yeah, so G2G, I got the same problem with you. 580 out of 583. I also don't know what the problem is. Yeah. Damn it. Recursive Boolean returns from children. Recursion will almost certainly TLE, I think. Because there are too many nodes. There are 10 to the power 5 nodes. You look at the size of this thing. This thing is like 10 to the power 5. 10 to the power 5. So if they make a tree that is just like vertically down, recursion will fail right away. So I don't think recursion works. Post your ranking, guys. Okay. Yeah, you guys should post your ranking. I'm not posting my ranking. My ranking is super bad. Let me see what my ranking is. It's going to be really bad. For sure. Yeah, I'll show my ranking. It's very bad. So that you guys can gloat over me. Oh, it doesn't even have my ranking. 3,000. Oh my god. It's because I got so many bugs on these two. If I didn't have this many bugs, I won't be as bad. 3,000 plus. This is not great. This is not it's not the worst ranking, but it's not a great ranking. Yeah, hopefully you guys got better ranking than me. Let me see. What else is in the chat? I got accepted when I traversed from N instead of starting. Oh, Swastik, you're talking about You're talking about question 3, right? If child returns Boolean, doesn't tell us anything about parent. Yeah, so G2G, that you're right. If the child returns a Boolean, that doesn't tell us anything about the parent being a palindrome. You look at this pattern, right? This tree, this parent up here is palindrome. It's A, B, C, D, C, B, A. So it's a palindrome. But it doesn't tell us anything about the children. That's the thing I don't get. The children not being palindromes doesn't tell you anything about the parents. The parent being a palindrome doesn't tell you anything about children. So this is the annoying thing for me. I don't understand what's the trick here. There has got to be some trick somewhere. Okay. Oh, nice. Rahanu Bari Tanvir. You got a better result than me. Because I got penalized 25 minutes for mistakes. Oh god. Yeah. Okay. Okay, cool. Folks, the contest is ended. We're going to go through all the answers. Okay, or at least the answers that I know. I'm going to go through them as well as I can. But before that, remember, if you didn't like and subscribe didn't subscribe yet, I would appreciate you subscribe to the channel. It will tell you when I live stream next. If you haven't liked the video yet, liking the video helps me a lot. So you just smash the like button. It's gonna help me a lot. So appreciate it, folks. Let me go through all the answers for all the questions one by one, and we'll go over each of them. Okay, but before that, I need to read my usual script for the algorithm. We are discussing solutions for LeetCode Weekly Contest 420. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. Okay, alright. Today's question contest has a lot of numbers. Like the points are pretty high, but they are not that hard. I think today's contest is really not that hard. Except maybe for the last one, which I didn't get. So hopefully you guys did well. We're going to go through each of the questions one by one. And we'll go through the first few ones faster because hopefully most of you got it. So the first question. Question 1. Find the sequence of strings appeared on the screen. You're given a string target. Alice is going to type target on her computer using a special keyboard with only 2 keys. Key 1 appends the character A to the string. Key 2 changes the last character of the string to its next character in the alphabet. So C becomes D, Z becomes A becomes B, so on and so forth. Okay, so you're supposed to write out all the things that Alice types. So basically there are 2 operations. The first operation is you can add one more letter. Add letter at the end. And then the second letter is to make the end letter go up. So the solution is quite straightforward. I think most of you got it. For each character that you have, you have to keep adding on. So for instance, if your target is ABC, for the first character, you just add A. Great. For the second character, you need A, and then AB. Because Alice's stupid keyboard can only increase move the last character by 1. Okay? And for the third character, AC, you get ABA, ABB, ABC. So these are the answers. And you should get an array of length 6. So what you want to do is basically 2 for loops. The outer for loop goes over the top character. The inner for loop goes over from A to the newest character. And if you append that will be your solution. Pretty straightforward. I don't want to spend too much time on this because the subsequent questions are more interesting. Use ChatGPT for the factor function. Okay, you know what? I'm not going to snitch on you. It's kind of fair because factor function, whatever, right? It's a standard function. If you want to be a great programmer, you're probably good at writing code in general. But for standard functions, you just copy from the internet. That's what you do in real life anyway. So question 2, count substrings with k frequency characters. So you're given S and K. Return the total number of substrings of S where at least one character appears K times. Okay, so to give example, so A B C B ABA is valid, ABAC is valid, ABACB is also valid because A appears twice in each of these. A appears twice in each of these, so these are all valid. And likewise, B, if you take out the first A, you start from B, BACB is valid, and that's the only one. Okay, so this looks like a classic sliding window problem, right? So the sliding window basically looks like this. You have your left pointer and your right pointer. When your left pointer equals to 0, is your left pointer. Your right pointer, you keep moving your right pointer until you are able to find 2 copies of any 2 characters. So in this case, your right pointer will be here, right? Your right pointer will be here. And how many? So if your left pointer is here and your right pointer, this ABA, okay? So for all strings starting from L, from 0, how many strings are there that are valid? Well, basically, for all strings starting from L, anybody longer than R is valid. So R, R plus 1, R plus 2, all the way to the end are valid. So there are 3 strings, ABA, ABAC, and ABACB. There are 3 strings. So how do you know there are 3 strings? You take the length minus R. When L equals to 1, you now need to move R. You have to keep moving R until you find the next one. So when L equals to 1, you no longer get 2 A's. You no longer get 2 A's. So your string BA is invalid. BA is not valid. Just now, when L equals to 0, you had ABA, right? You had 2 copies of A. When you move L to 1, you are left with 1 copy of A. Now ABA is not valid. So you keep moving until you have 2 copies of any character. So the only place this happens is right at the end. So your R is right at the end for BACB. Because R is right at the end, there's only one valid string where this is true. When L equals to 2, R can go all the way to the end, it's still going to be invalid. So this is 0. And because you can't find any valid string starting from index 2, it means that any string starting from greater than 2 is going to be 0 also. So it can break here. So that's the basic general strategy. Your L keeps going. When L, and if for each L you find the first R that contains 2 copies of the same letter. And you increase the total by the length minus R. And then your L goes up and your R keeps moving again. Okay? So the trick here is that for every L, your R doesn't have to start from beginning. Your R keeps you keep searching from the previous value of R. In order to do that, you basically have to remember how many copies of each characters there are. So here is the code. Oh, whoops. So here is the code. Looks like this. You look like this. This is very standard sliding window. So this is a sliding window. I move R until I have k times. K times is larger than 1. So I keep this count. Count is the is the frequency of each character that appears in between the current L and the current R. So I keep moving until there is at least one character whose count is k times. At least one character whose count is k. So when that is true, I can break. Okay. And so now that I know what my R is, my result will plus equals length of S minus R plus 1. So I do this because, coming back to this, when r is this, I know, so r is 0, 1, 2, and length is 5. So it's 5 minus 2. Well, actually r is 3. So 5 minus 3 plus 1. So I'm counting how many valid strings there are that start from L and end at R or later. So this will give me the number. And when after that happens, what I do is I move L by 1. Because I move L by 1, right? I need to reduce the count of the leftmost char by 1. So in this case, when I move from L equals 0, L equals 1, I have to remove count. So initially here, for count, A equals to 2, B equals to 1. So when L equals to 1, A equals to 1, B equals to 1. I have to reduce the count of A by 1 because I no longer this guy. So that's what I'm doing here. So after that, you just you just check. So I have this k times variable here because I want to make it a bit faster. I don't have to go through counts every time to check whether there's a char that's at least k or not. So if you run this should give you the right answer. So VJ Vishal, thanks for the help. No problem. This is my pleasure. I did a prefix count and substring enumeration for this. Prefix count. What do you mean by prefix count? Are you talking about question 4 or question 2? Okay. Question 2. You did a prefix count. Let me see. Let me try to understand a little bit what you mean by prefix count. Oh, okay. You count how many times. I see. Oh, yeah. That may work too. So when you know that this character has one copy of yourself before it, then yeah. Okay. That may work too. That might be faster. Yeah, that's a good idea. Okay, so question 3. Minimum division operations to make array non-decreasing. You're given an array nums, and then this is a proper divisor. You're allowed to perform an operation, and each operation you select one number and divide it by its greatest proper divisor. And then you count how many operations needed to make the array non-decreasing. So basically, for example, here 25 and 7. Is this non-decreasing? This is not non-decreasing. So I'm going to take 25. I'm going to reduce it by dividing it by its greatest divisor. And then I get 5 and 7. And this is going to be decreasing. Okay. So the way to look at this is, I think it's pretty straightforward. So logically, you have to go backwards, right? So if you have a lot of inputs, right? Numbers can only go down. So if you want this number to be smaller than this number cannot go up. You can only make this go down. So it makes sense that you start from the last number because the last number cannot change. And then you make the second last number go down as many times as needed until it fulfills the requirement of being smaller than the last number. And then you keep going on and on. So the basic loop goes backwards. And in each loop, you just reduce the number as many times as needed by dividing by its greatest proper divisor. Okay? So that's all there is to it. This is actually, I'm surprised this is like a medium problem. This looks more like an easy problem. Okay. So the first thing to do is to find a way to find the greatest divisor that is fast. Okay, so once you have a factor, a way to a function that finds the divisor quickly, what you then do is you go backwards, and then for each number you have a while loop. You keep dividing by its largest factor. And if the factor is -1 or you get to a weird place, then you return -1. It's not going to work. Otherwise, you divide by its factor and then increase the number of operations by 1. Okay, so how do you find the greatest proper divisor as quickly as possible? This is the fastest way that I can think of, which is you start from 2 and then you go up to square root of n. You go from 2 to square root of n, and then what you do is you check if n is divisible by f, then you return n/f, which is n divided by f. So basically, if I want to find the largest square root of, say, 999, instead of going 998, 997, this is very slow, right? I don't want to do this. What I'll do is I'll start with 2. 999, is it divisible by 2? No. 3, is it divisible by 3? Yes. So the largest factor is then n divided by f. So 999 divided by 3 equals 333. So this will get you the greatest proper divisor as quickly as possible. I think this is the fastest way to do it without doing any like C shenanigans. Yeah. So if your for loop starts from 999, 998, 997 and goes down, it's going to be slow. You can make this a bit faster by going from 999 divided by 2. But in this case, I made it even faster. I only checked 2 numbers. You start from 999 divided by 2, that is like 445. And then from 445 to 333, you have to keep going. So this is actually much faster. You start from the smaller divisor and then you work your way up. Other than that, I don't think there's anything too interesting about this problem. Okay, cool. All right, so question 4. Question 4. I've tried it. I got a TLE. I got most of it, but I didn't manage to do it. I'm curious what the actual answer is. So you're given a tree rooted at 0, consisting of n nodes from 0 to n-1. The tree is represented by a parent of size n. So it's a parent array. So the parent array tells you who the parent of each node is. Every node has exactly one parent except from node 0, which has no parents. You are also given a string of length s, where si is the character assigned to node I. Consider an empty string, define a recursive function, blah blah blah, that takes a node x as a parameter and performs the following steps. Iterates over the children, and then add yourself to the end. So this DFS basically is a post order traversal. So this post order is very important. It's not infix, it's not prefix, it's postfix. So it's post order traversal, which means you call children first, then you call yourself. Okay? So this part is pretty important. Okay, so DFS is shared, blah blah blah. We don't care about this. We need to find a Boolean array answer of size n, where you do the following. If the result DFS is a palindrome, then set answer I to true, otherwise set answer I to false. So basically, you have to calculate the DFS string for every node. So let's do that first. So this is the parent array. Look, this parent array 0 has no parent. This index 1's parent is 0. Index 2's parent is 0. Okay, that's how to read a parent array. These guys are the parents of the nodes at each index. Okay, how do you calculate the DFS string? Well, it's a post-fixed traversal, which means for these guys are going to be A, B, and A. Very simple. Okay, this guy is a postfix, so you look at his children first. His children is A, then yourself is B. This guy, same thing, is children first. Children is A, and B, and then yourself A. So ABA. So number 1, DFS1 gives you ABA. So DFS 0, you write its children down first. So ABA, AB, and then yourself A. ABA. So this will be the post-fixed traversal of yourself, the post-order traversal of the tree. Okay, so these are all the DFS strings. Once you calculate the DFS strings, you must now calculate if they are palindromes. So is this palindrome? Yes. This, yes. This, no. Yes. So the answer is true, false, true. True, false, true. So that's what the question is asking about. So if you think about it, there's actually 2 parts. Part 1, calculate the DFS string. Part 2, for each DFS string, check if it's a palindrome. So the way I did it, I'll just show you guys the way I did it. So the way I did it is, I was a little bit leery about this. When I saw this problem, I know that the tree can be really large. The tree n is 10 to the power of 5. That's really large. So if I'm not careful about calculating the DFS, like this tree is basically, they tell you what its parent is, right? You cannot easily get the children of a particular node. So if I'm not careful about this, I'm going to run out of time. So I need to do this very carefully. So what I did is the following. First I calculate all the children. It makes sense, right? I'm going to need to find the children of each node. If I don't do this step, it's going to be very slow. And this step is very fast because it's O(n) time. As long as I do things in O(n) time, I should be good in theory. Okay, next step. What I want to do is not yet. So next thing I want to do is I want to go to each child. And what I want to do is I want to have a to-do list. Right. So once I have this children, right? So, okay, let me take a step back. So how do you calculate DFS? If you want to do DFS, normally what you want to do is you want to have a recursive function, right? Your recursive function to go down. But I was very scared about recursive function because of how many nodes there are. There are 10 to the power of 5 nodes. So if the tree looks like this, if the tree is like this, it has depth 10,000, then my recursion stack will be size 10,000. And Python does not allow that. Python's maximum recursive depth is only 1,000. And either way, no matter what, this is not going to work. I don't think this is fast enough. I think it's going to take up too much space also. So I didn't do it recursively. Instead, what I did is to use, and this is a very common pattern, you use some kind of work queue. To do equals something while len to do greater than 0. While there are things in the to-do, they are greater than 0. So what I did is I put the to-do to be everyone, all the leaf nodes. So I start the to-do with all the leaf nodes. So this 3, 4, and 5 are the leaf nodes. So my to-do will have 3, 4, and 5. And while to-do is larger than 0, what I want to do is I want to construct the DFS string for all the to-dos. to do. And then when I've done that, I check if my parent, if all the children of my parents are done, add parent to do. Okay, so at first my leaf nodes are 3, 4, and 5. 3, 4, and 5. And after I compute them, I check, is my parent completely done? So when I process 3, I calculate A. I check is his parent completely done? No, not yet. I haven't done 4 yet. So when I do 4 is done. I check, is parent 1, is it done? Yeah, it's completely done. So I add 1 to do. And likewise for 5, after I've done with 5, I check is parent. Is parent is 2. In this case, parent only has 1 child, so it's already done. So that's great, and so on and so forth until I reach the end. So this allows me to calculate all the DFS strings without duplication. So I only compute each DFS string once. Okay, and that's what's happening here in this part of the code. So to do is set. First, I add all the leaf nodes to do. And then what I do is I count the number of children that are done for each node. So while my length of to do is true, I construct the DFS by going over this guy's, all of this guy's children. And then I'm going to append myself. And then I'm going to construct my own DFS string. This constructs my DFS strings. After I've done that, I check whether it's a palindrome. If it is, I set it result to true. If not, I keep continuing my life. And then now I check for my parent. I'm going to increase the number of done children of my parents by 1 because I'm done. And I'm going to check if all my parents' children are done, I add my parent to do. And I keep doing until I keep doing this. I keep repeating this cycle until my entire tree is done. And once that happens, I can return result. So this actually produced the right answer. But it TLEs. I don't know why. Maybe now I'll know. I'll just take a look. Why does it TLE? It's probably some insanely large number. Oh my god. Oh, interesting. Okay. Oh, interesting. So basically this is a vertical tree. Oh, this is a vertical tree. So this tree looks like this. 0, 1, 2, 3, all the way to whatever this number is, 10K or whatever this number is. So it's a vertical tree. And not only that, the other thing about this input is that every character is the same. Yeah, every character is the same. So S is just a bunch of Z's. So every character is the same. Yeah. So I think what happens is then I construct the palindrome, right? Yeah, I construct the palindrome and it's all the same. I wonder if there's a very easy way to fix it. So if your child, you have only one child and it's a palindrome. Yeah, I wonder if there's some heuristic to fix it. If you only have one child and your child is a palindrome, for you to also be a palindrome is impossible. Oh, it's possible. But only if that child. Yeah, I don't know. I have to think about it a little bit. Yeah, I don't know what the right answer is. But anyway, that's where we're at. I think it's a justifiable exam. Is a good try, but it just doesn't work. If somebody knows what the answer is, let me know. If not, post your post your result in the comments. I'm curious what your results are going to be. Either way, thanks a lot. I think this is the end of my stream. I hope you guys did well for this contest. I think I didn't do too badly. It was average. Hopefully I'll do better next time. And hope to see you guys next week. Bye for now.